We're going to look at the least common multiple using the prime factors method. We'll go ahead and look at what it means, what the least common multiple is. We're going to also examine the steps in finding the least common multiple, and then we will go ahead and apply those steps to find the least common multiple of a set of numbers. So the least common multiple is taken from the multiples of a set of numbers, and the least common multiple is usually the smallest number from that set of common multiples. It's also known as the smallest common multiple or the lowest common multiple. And when you have a list of prime numbers only, the least common multiple is the product of all the prime numbers. Now, to find the least common multiple using the prime factor method, we'll develop factor trees for each of the numbers in the set. We'll express the numbers as a product of the prime factors. We'll identify the unique prime factors and multiply them together to determine the least common multiple. Let's put that to use. Let's put that to practice. So 8. Let's write our numbers. We have 8, we have 18, and then least common multiple. So let's start with 8. 8, we have 2 and 4, 2 and 2. So this is going to be 2 times 2 times 2. And then for 18, we have 2 and 9, and then we have 3 and 3. So we have times 3 times 3. Now here's where it gets interesting with the least common multiple. What we're going to do is, so we have 2's right here. We're going to take all the largest occurrences of 2. So we have 2 times 2 times 2. That's the one that occurs most often. And even though there's no 3 for 8, we're going to use 3 times 3. So this is going to give us 8 times 9, which is 72. So here's the rule. You're going to pick up all the unique occurrences, but you're going to use the one that occurs for each of the factors or the prime factors. You're going to use the one with the largest frequency or that happens the most. When we do a few more examples, you'll see what that means. So let's look at 16, 20, 24, and then least common multiple. So let's look at it this way. Start with 16. We have 2 multiplied by 8. 8 is 2 multiplied by 4. And 4 is 2 multiplied by 2. So we have 2 times 2 times 2 times 2. Let's go ahead and deal with 20. We have 2 multiplied by 10. 10 is 2 multiplied by 5. So we have 2 times 2 times 5. Now let's look at 24. We have 2 multiplied by 12. 12 is 2 multiplied by 6. 6 is 2 multiplied by 3. So we have 2 times 2 times 2 times 3. Now, what we're seeing here is we have 3 unique prime factors. We have 2, 3, and 5. So let's start with 2. Let's see, in 16 we have 4 times, in 20 we have 2 times, and 24 we have 3 times. So we're going to pick the one that occurs 4 times. And then for 3 we have 1 occurrence, and for 5 we have 1 occurrence. So this is going to be 16 times 3 times 5, which is going to give us 48 multiplied by 5. So that should be 240. Another example, 27, 45, 63. Now we'll look for the LCM. So 27, we have 3 and 9. 9, we have 3 and 3. 45, we have 3 and 15, we have 3 and 5, and then 63, we have 3 and 21, 3 and 7. So 27 is 3 multiplied by 3 multiplied by 3. 45 is 3 multiplied by 3 multiplied by 5. 63 is 3 multiplied by 3 multiplied by 7. So now we're going to look at, we have 3, 5, and 7. So for 3, we have 2 occurrences for 45 and 63, and 3 occurrences for 27. So we're going to pick the one with 3 occurrences. 3 times 3 times 3. Then we have 1 occurrence for 5 and 1 for 7. So this is going to give us 27 times 5 times 7. So we can say this is 27 times 35. And then we can work that out here. 27, 35. You multiply that through. 7 times 5, that's 35. We have 5, we bring up 3. 2 times 5, 10 plus 3. We have 13. Now we put a 0 here. 7 times 3, we have 21. 1, we carry up 2. 2 times 3, we have 6. Plus 2, we have 8. So now we add this together. We have 5, 4, 9. So this is going to give us 945. Final example, we have 48, 72, 96, and then 120. And we're going to find the LCM for this. So I'm going to use the other method I used. So 48, we're going to have 8 times 6. 6 is 2 times 3. 8 is 2 times 4, which is 2 times 2. So 48 is 2 times 2 times 2 times 2 times 3. 72, we have 8 multiplied by 9. 8 is 2 by 4. 4 is 2 by 2. 9 is 3 by 3. So this is 2 by 2 by 2 by 3 by 3. 96 is going to give us 12 multiplied by 8. So 12 is 2 by 6. 6 is 2 by 3. 8 is 2 by 4. 4 is 2 by 3. So 96 is 2 times 2 times 2 times 2 times 2 times 3. And then 120. 120 is, we can say, 12 multiplied by 10. 12 is 2 by 6. 6 is 2 by 3. And 10 is 2 by 5. So 120 is 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. So LCM, we have 2, 3, and 5 as the unique numbers. So let's start with 2. Here we have 4 occurrences. Here we have 3. Here we have 5. So we're going to use that. 2 times 2 times 2 times 2 times 2. And then 3. Here we have 1 occurrence. Here we have 2. Here we have 1. We have 1. So we're going to use the one that has 2. 3 times 3. And then we have 1 occurrence of 5. So this is going to give us 32 times 9 times 5, which is 32 times 45. Let's solve that here. 32 multiplied by 45. 2 multiplied by 5, 10, 0. Bring 1 up here. 3 times 5, 15, plus 1, 16. So we'll put a 0 here. 2 multiplied by 4, we have 8. 3 multiplied by 4, we have 12. We put 2 here, bring 1 out here, and then we add this together. So this is 0. This is 4, 4. So this is going to be 1440.